Okay, so I'm going to broach a topic that might be controversial or might not be, depending on how open-minded you are. But there's an idea in physics that has sort of formed the basis of all of modern cosmology, and that's Hubble's law. And Hubble's law is just this amazing feat of observational science, where Edward Hubble uh, was able to, and this is just insane that this first observatory that was built, and they were finally able to know how far away stars were, which isn't an easy feat, and how fast these stars are moving away from us, which also isn't an easy feat. And then he made this sort of graph that's over here on the left side, um, where he showed that stars that are twice as far away are moving twice as fast. Stars that are 3 times as far away are moving 3 times as fast. Now, the conclusion that we got to from this, is that we're in an expanding universe. Now, and this expanding universe is what gives rise to the idea of dark matter. Now, don't get me wrong, I love this idea of an expanding universe, but just the fact that I love it doesn't make it a true idea, right? I mean, I love elves and dwarves, right? Doesn't mean they're true. I love, I don't know. I love dragons. Doesn't mean that's true, right? But it makes sense that there's an expanding universe if Hubble's law is constant. If Hubble's constant is constant. And we call it Hubble's constant, okay? But the thing is, what if it's not constant? How long will we have to wait? Like, how old is the universe? Billions of years? How old is the Earth? 4 billion years? The universe is like 15 billion years old? So think about this. The universe starts 15 billion years ago. That means, well, if Hubble's law isn't constant, it'll take us 10% of that time, which is 150 million years, in order to see Hubble's constant change by 10%. 150 million years. When did we discover Hubble's constant? 100 years ago? It makes sense that if Hubble's law isn't constant, we would still measure it as constant, right? And if you're not following me, I'm just going to give an example. I'm going to give an example because it's a lot to hold in your head and to work out. But the idea is, let's say you took a ball of marbles, okay, and you put an explosive device in the middle of those marbles, and say this explosive device worked in outer space. You take this huge array of marbles and you explode it in outer space, okay? And what happens? Every marble is moving at a different velocity, okay? And after 1 minute, the marbles that are moving twice as fast will be twice as far away. That's just the way it'll work. Okay? A marble that is moving 100 meters per second in 1 second will be 100 meters away. And a marble that is moving 50 meters a second in 1 second will be 50 meters away, right? Half, twice as fast, twice as far away. If you wait 2 seconds, 200, 100. 3 seconds, 300, 150, right? Always, whatever's moving twice as fast will be twice as far away. But Hubble's constant says that the velocity, we can predict the velocity based on how far away it is, okay? Now that doesn't make sense for the marbles because the velocity isn't changing. But let's say we waited 100 million years. What's going to happen? The velocity of the marble is going to look like it's based on some law of how far away it is, how fast it's moving. Because you give it 1 more second, this constant isn't changing. You give it 2 more seconds, 10 more seconds, a year, the constant won't change because it's so far away already. To see a small change in that constant, it'll take another 1,000 years, 2,000 years, right? So I'm not saying the universe isn't accelerating. I'm not saying that, but I'm saying how are we so sure that it is? Okay, how are we so sure that Hubble's constant is constant? How are we so sure? Hubble's constant could be a function of time, right? it could be that the initial energy that everything had, it got this initial velocity, and that velocity never changed, right? Maybe it slowed down a little bit, but that velocity overall didn't really change, and that's why things that are twice as fast are twice as far away, because we all started at the same point. Okay, so it's just food for thought, and like it's not that I'm afraid of dark matter. I've got maybe 5 theories on dark matter already that I can propose, right? It's not like it doesn't make sense, right? Dark matter might be a reality, right? And dark energy might be a reality. It's just that we should examine these more rational, um, I guess Occam's razor, whatever's we should examine that first, right? Whatever is more logical, we should examine first. Like to dream up this new crazy idea of dark matter, like that, it's a valid solution if Hubble's law is constant. But I mean, do we know Hubble's law is constant? Not really, right? But anyways, I really like the idea of an accelerating universe. I just don't think we need to go there yet. Um, okay, have a good one.